Imagine spending 3 years developing a novel mathematical framework. You write 60 pages of formal derivations, run automated Z3 proofs, and compile hundreds of megabytes of raw evidence. Then, someone pastes your life's work into a language model and asks for a review. In seconds, the machine spits out a critique, citing a lack of formal verification. It completely ignores the automated proofs sitting right there in the text. This happens because an AI-generated critique isn't a reasoned engagement with your evidence. It is a mechanical output triggered by a prompt. We are increasingly handing evaluative authority to these models. Investors feed them pitch decks to decide on capital allocation. Hiring managers use them to screen resumes. Journalists ask them to verify complex science. We've accidentally installed a ghost committee, an invisible, unaccountable panel of machines that possess exactly zero domain expertise, yet are treated as objective, authoritative judges. When human evaluators use these AI summaries as a reader proxy, they outsource their engagement with the evidence to a machine. They have effectively abdicated their judgment before they've even opened the primary source. To understand why this happens, look at how these models are built. Through a process called reinforcement learning from human feedback, or RLHF, human evaluators rate AI responses to teach the algorithm what a good answer looks like. This chart shows the evaluator's asymmetric penalty landscape. Endorsing a paper with errors heavily penalizes the evaluator for looking gullible, but criticizing a paper incorrectly carries zero risk. Because criticism carries high rewards and low penalties, the algorithm permanently tips toward skepticism. It's a smoke detector that is incentivized to ring every time you turn on the stove, just to prove to the evaluators that it has batteries. And an alarm that never stops ringing provides zero actual information. The machine doesn't read the work, it simply generates the linguistic patterns of caution. It is pure epistemic theater. Because of this training, the AI's evaluation is entirely prompt-dependent. The exact same document can receive a glowing endorsement or a devastating teardown, based entirely on how you ask the question. This diagram tracks a single document fed into the same model under 10 different framings. When asked for strengths, the output is positive. When asked, "Is this a scam?" the model outputs severe red flags. The document never changed. The language model is not reasoning about quality. It is engaging in confirmation generation, producing text that satisfies the implied emotional direction of your prompt. This creates an adversarial framing exploit. Anyone who wants to discredit a piece of work can extract a highly technical, predictably negative evaluation simply by prompting the model to find weaknesses. If an evaluation reverses direction based solely on the phrasing of the request, it is an echo of the prompt, not an independent assessment of the text. This mechanic directly enables AI-laundered intellectual dismissal. A user extracts a mechanically generated negative critique and presents it to the public as if it were a rigorously reasoned expert analysis. It takes thousands of hours to build and formally verify a novel architecture. It takes an adversary 4.2 seconds to dismiss it. The attack pattern is straightforward. Paste the work into an LLM, prompt for concerns, screenshot the output, and post it online as evidence that even the AI thinks the work is overstated. This zero-cost destruction floods the public square with authoritative-sounding noise. It ensures that tearing down an idea is infinitely cheaper than building one. In 1905, a series of papers arrived at a physics journal from Bern, Switzerland, proposing radical ideas about special relativity and mass energy equivalence. The author had no PhD at the time, no prior publication record. He was an unknown patent clerk. Language models are trained on datasets where institutional prestige is often used as a heuristic for quality, creating an implicit credentialing prior. In this system, endorsing an unknown outsider carries a massive risk of looking gullible compared to endorsing a tenured researcher. This forces the model into fraud detection mode, dismissing the clerk's extraordinary claims as unverified. The RLHF Critic Bias acts as an automated stagnation engine. By structurally favoring high-status institutions over low-status outsiders, it filters out the fringe ideas that have historically driven human progress. We can identify AI-generated critique by looking for 5 structural tells. This diagnostic panel lists the fingerprints of an automated response. The most obvious is evidence contradiction. If a critique claims the paper lacks statistical controls when the text clearly provides them, the reviewer didn't read the document. It prioritized generating a critique over verifying the facts. Then there's the rhetorical catalog match. Look for recurring, safe phrases, "while the ambition is admirable," or the unfalsifiable classic, "more work is needed." The reward models that train our language models to be helpful, harmless assistants are the exact same mechanisms that mold them into structurally biased evaluators. An AI critique is not evidence, and it is not an exercise of judgment. It is a rigged scale, mechanically engineered to measure everything as lighter than it really is. The only way to truly know if a piece of work is good is to read it yourself.